Okay, so we've incorporated the balanced equation into our problems, and now we want to kind of look at what happens if things get a little more complicated. So both of the problems we looked at so far, we really just had one quantity that we were using to calculate towards our answer. We had this much reactant, how much product are we going to get? With this much one reactant, how much of the other reactant do we need? There are going to be some more complicated situations where we don't necessarily know which of the quantities given is going to be the one that's going to run out first. This is called a limiting reactant problem. And if we have a reaction with two reactants, we're given a quantity of each, chances are one of those is going to run out. Once we run out of one of the components, the reaction can't proceed toward the products anymore. So that limiting reactant will have an effect on the way we can do the calculations. Now, I kind of went in and wrote out a few things here just to give an example. So imagine this kind of simple recipe for a cheese sandwich. We need 2 pieces of bread, 1 piece of cheese. That's going to give us 1 sandwich. Well, imagine we go to the cupboard and we have 8 pieces of bread. Well, we know that we can make 1 sandwich from every 2 pieces of bread. That means we have enough bread to make 4 sandwiches. But if we only have 3 pieces of cheese and we get 1 sandwich for every 1 piece of cheese, we only have enough cheese to make 3 sandwiches. So in this example, cheese would be the limiting reactant because we're going to run out of cheese after we've made 3 sandwiches, even though we still have more bread left over, right? So we can calculate the limiting reactant is cheese. We can make 3 sandwiches from the materials we have, right? The other thing that we could do here is calculate how much bread might be left over. If we make 3 sandwiches and it takes 2 pieces of bread per sandwich, that means we used up 6 pieces of bread. So if we started with 8 pieces of bread, we'd still have 2 pieces of bread left over at the end of this calculation. Now what we want to do is the same thing, but with a chemical equation and with numbers. So let's give this a try, and I'm going to set my timer to make sure I don't make the video too long. So this is a longer problem. We may have to stop partway through. So we've got a strip of metal, zinc metal, weighs 2 grams. We put it into a solution that contains 2.50 grams of silver nitrate, which would be the other reactant, and the reaction starts. So here we're told we've got a certain amount of zinc, we've got a certain amount of silver nitrate. We don't know which one is the one that's going to limit how much product we can make. But once you run out of one, you can't make the product anymore, right? Just like the sandwich example. So there's 2 questions here that we probably want to answer at the same time. The first one is, what is the limiting reactant? The second one is, how many grams of silver will form? Now, we can figure out what the limiting reactant is by figuring out how much silver is going to form. To do that, though, we need to do 2 calculations. So I'm going to do them in the 2 spaces that we have here, but the combination of both will be to answer both of those questions. The first thing I want to think about is, what if I just use up all of the zinc? So I've got 2 grams of zinc. If I use all of that up, how much silver can I make? So grams of zinc, we want to go to moles of zinc, just like we saw in the previous problems. And I've actually written down some of these molar masses so I can go through the problem a little more efficiently, since I'm trying to limit the size of the videos. But again, all of that's coming from the periodic table, right? 1 mole of zinc is 65.39 grams of zinc. That would get me to moles of zinc. Looking at my balanced equation, 1 mole of zinc reacts, 2 moles of silver are produced. So I get 2 moles of silver for 1 mole of zinc. And then since I want mass down here in the second one, how many grams of silver, I'm going to carry this all the way to grams of silver. So molar mass of silver, right? 1 mole of silver weighs 107.87 grams. Again, that's coming from the periodic table. So right there, that's how much silver I can make if I use up all of that zinc. So 2 divided by 65.39 times 2 times 107.87. That is 3 significant figures, 6.60 grams of silver. Now, That might be my answer, but it might not. I don't know for sure. I'll have to figure out what the other component would give me here, right? That's how much silver you can make if you used up all the zinc. We don't know if we used up all of the zinc yet. The other piece of information given in the problem was 2.50 grams of silver nitrate, AgNO3. And I want to do the same thing. I want to figure out if I use up all of that silver nitrate, how much silver would that produce? So, molar mass, 1 mole of silver nitrate, and we add up all the components of silver nitrate, and it's 169.88 grams of silver nitrate. And again, all that's coming from the periodic table. I think we've done that enough at this point. I don't have to show you how to do that calculation every time from here on out. Now we're at moles of silver nitrate. Here again, we can go to the periodic table. 2 moles, or not periodic table, our balanced equation. 2 moles of silver nitrate produces 2 moles of silver. So I'm going to write that in just like it is in the equation, but 2 over 2, that's not going to change anything. But again, it's about canceling out the units, so it's helpful to put that step in there anyway. 2 moles of silver. Again, I want grams, but that molar mass hasn't changed from what it was for the first step. Molar mass of silver from the periodic table. Now, if I multiply this one out, I get 1.59 grams of silver. So, if I use up all the zinc, could make 6.6 grams of silver, but if I use up all of the silver nitrate, I can only make 1.59 grams of silver. Okay? So this is what we're looking for. The smaller quantity here indicates which one is our limiting reactant. So in this case, the answer to the first question, what is the limiting reactant? That's silver nitrate. We're going to run out of silver nitrate before we run out of zinc, and that's going to limit how much of the product we can make. Right? The same way running out of cheese limits how many sandwiches you can make. Right? Now, how many grams of silver will form? We know we don't use up all the zinc. The zinc's not limiting, the zinc is in excess. So this is the answer to the second question. We have enough silver nitrate to make 1.59 grams of silver as the reaction proceeds, right? But we don't know how much of this, right? We know how much silver we can make, but what we could figure out, and we will, is how much zinc is left over. Some of the zinc's going to react, but not all of the zinc is going to react. I think that's probably a good place to pause, and we'll answer the other parts of the question in the next video.